mic is working. So thank you all for coming to see us today. There's a lot of great stuff here, so we appreciate you choosing us. I think it's going to be worth it. My name is Lindsay Maiko. I am the head of data science for Providence. I'm joined by Dalo Wu. He's an engineer and architect. We'll be co-presenting this talk today. We're going to talk today about a data-driven tool that we've been building for the last year or two, actually maybe a little more than that, to solve what I think is the most pressing operational problem in healthcare today, and that's hospital overcrowding, or throughput, right? Critically, we're going to tell you how we did it with the scale, the power of the Azure cloud. We have a strategic partnership with Microsoft, and how we use the Databricks tools, their streaming tools, the lakehouse architecture, all the fabulous things in their toolkit to make this work. It was not a trivial effort, but we didn't need 100 engineers to build this. Like, the tools are really good, and we've really appreciated our partnership with Databricks. So, first about Providence. There's a bunch of really big numbers on the screen. We're a very large, not-for-profit healthcare system. I think we're the fourth largest in the US. We're certainly one of the largest. We see tens of millions of patients every year. We've got over 100,000 employees, on about almost 30 billion in revenue. So we're also like a big corporation. We are not-for-profit, though. Our mission is to serve the poor, the needy, and the vulnerable. And I want to draw your attention specifically to that upper right number, 2.1 billion in community benefit. This is like charitable contribution, giving back to our communities. And most of what this is, although there is direct investment, most of this is unsubsidized care for the poor and the needy. This is largely Medicare, Medicaid, the uninsured. And to be clear, we're happy that that number is really big. This is why we exist. We've been around for over 100 years to do this. We want a big number there, but we also want to make sure that we're using that money in a really efficient way. And there are, if you're alive in the world today, right? You've been in US healthcare, it's not super efficient. So, if you guys can remember back 3 years and change, right, to the COVID times, to lockdown, it was like every single day in the news you would hear about hospitals being full to the brim, right? They were packed, they were under strain, we were concerned they were going to be overwhelmed and unable to provide care. I personally assumed that when we transitioned to a more kind of steady state, stable COVID phase like we're in today, that this issue would go away. But unfortunately, these are recent headlines. It has not gone away. Hospitals in the US are overcrowded. People are having a hard time getting discharged. There's a lot of reasons why. We'll talk about them in a minute here. But this problem has not gone away, right? So this has impacts to patient care. It has impacts to our financials. It has impacts on our caregivers. It's just a bad situation all around. So, what's going on, right? It's not COVID anymore, right? Why are we so packed to the gills? One big driver is that coming out of COVID, the patients that are arriving are more challenging to deal with. You have increased incidence of mental health issues, substance abuse, housing instability. If you walked to the Moscone Center, you probably saw it out there on the street, right? I live in Portland. It's everywhere, but you could literally see it right out the door here, okay? There's also patients with chronic health conditions that were undermanaged, poorly treated through COVID. They were delaying care, okay? So they're now sicker than they would have been otherwise. This just means patients take more time. The flip side of this is we've seen huge losses in our workforce, okay? Caregivers, frontline clinicians, they burnt out. It's been a very stressful 3 years. I'll say even in the data department where Dalo and I work, it's been a very stressful 3 years. There's a lot of pressure. It's 10x in the clinical setting in a hospital. Okay, so people have left, they've retired, we have fewer caregivers. You put those things together, and what you end up with is an overcrowded hospital, which generates delayed care, right? And then it comes all the way back around, right? And you end up with sicker patients. And that's more challenging. There's more workload, there's more burnout, more people are leaving the system. So we're in this like kind of terrible, vicious feedback loop. Now, you know, I'm a data scientist, Dalo's an engineer. We can't like go out there in the hospital and like solve this problem, right? We're not gonna, you know, staff a nursing bed, but we can bring data and analytics to bear to help clinicians who know what to do, but need information at the right time to be able to do those things. So we've built a product, we call it Envoy. I'll show you a screenshot in a minute here. And critically, we built it from the perspective of a nurse and a nurse supervisor, right? So if you've been in the hospital, you know that nurses are doing a lot of the heavy lifting. I don't personally think they get the attention that they deserve. And so we've built this product with them and for them. And at the very beginning, we went and said, like, hey, like what do you need? Like, what's your experience with data? How do we build this for you? And we pretty quickly surfaced like some issues. You can see them on the screen here. Is like it's a lot of manual data entry. The UI sucks, right? Just kind of doesn't meet modern standards. And most critically, right, is that the information that they're getting is too late to take action on. Okay. In healthcare, we're often looking, and this is, you know, BI in general, but it's exacerbated by the kind of tech stack of the electronic medical record. We're often looking retrospectively, right? That doesn't help you deal with the situation that's unfolding right now, or even more importantly, in 12, 24, or 36 hours. So to give you a sense of just like what like this like, you know, discussion of overcrowding really means operationally, and like kind of where some of that 2.1 billion comes from. This is a vignette on heart failure, okay? Just like one type of issue that we see in the hospital setting. So going back to the beginning of COVID, Providence has invested over 120, or lost, you know, right? You kind of like see it from both angles, over 120 million in unreimbursed care on heart failure alone. U.S. healthcare, again, it's weird, right? The federal government sets a reimbursement rate. It's like, we think it should take 4 days to care for someone with heart failure, right? And we're gonna pay you based upon that assumption, regardless of how long it actually takes. Now, unfortunately, right now, about half of patients are staying longer than 4 days. And you can see as the numbers go over there, like you very quickly start losing money. Now, for Providence as not-for-profit, like we're not looking to generate a positive margin so that we can take profits and give them to shareholders. This is so that we can invest back into our system, so that we can do raises, we can improve infrastructure, we can like make direct investment in communities, right? So having losses like this undermines our ability to serve our mission and just be functional as a system. So how are we going to bring data to bear, right? The first step is we need to model out how a patient enters and flows through the hospital. And for what it's worth, we spent a lot of time thinking about this slide because our early version of this was like a mess of spaghetti, okay? Because the way patients can actually enter and flow through a hospital are very, very complex, right? It's not a factory line. You know, ultimately we stripped it down. And what I really want to call your attention to is on the left side of the screen, these are ways people can enter a hospital. Some of them are planned, right? You can make good, you know, operational decision making a few weeks out, like the scheduled surgeries. We know when somebody's going to show up, they're going to get a surgery. We can plan for that. We can staff for it. But like, there's a lot of patients who are entering the hospital system stochastically, all right? Like, and these can be modeled, right? And that's what we do as data scientists. We predict the future for a living. But those models, those predictions have not been available until we built Envoy on top of our streaming data platform. So as you can see, patients are admitted, and then they can go into different units. The problem is that as those units fill up, new patients can't come in. Okay, so that's the bottlenecking part. So being able to predict how many patients will be where, how sick they'll be, and what they're going to need is kind of the crux of what we're trying to get to. So Envoy is a data-driven solution. It has a modern UI. It gives unit-level information in real time around patient occupancy, around acuity. You can go down to a patient level. It can be customized for each individual. They can rebuild it every day if they want. They can have multiple versions. They can share it. They can set alerts. Okay? This can be used by an individual nurse for their own patients. It can be used by a hospital administrator. It can be used by an executive who's like, hey, what's going on at that hospital down the street? Okay? They can see what's happening right now in that hospital. The part that I'm most excited about, because I'm a data scientist, is that we're now building AI and machine learning into all facets of it, right? So like this is, trying to carry on the momentum of this morning keynotes is like build AI into everything. Like we are trying to build AI into all of this, right? So you can see what's coming next and you can start preparing for it. To get to this point though, we had to do quite a lot of engineering work. It's non-trivial to be able to ingest, process data at the scale we're at 52 hospitals. So we had to build a streaming data platform. I'm going to pass the mic to Dalo to tell us about that.
All right, thanks, everyone. Thanks, everyone, for attending. Today, I want to talk real quick about our streaming data platform that we built in collaboration with Databricks and Microsoft. Let's just jump right into it. So this is our architecture diagram at a very high level. So before we start, it's worth mentioning HL7. If you're familiar with HL7 message, it stands for Health Level 7. It is a standard for systems to communicate clinical and billing information between systems. So the way it works at Providence is that we have Epic as our main health systems deployed in pretty much every region, hospitals that we have. And Epic provides real-time HL7 messages through our core point engine. Our core point engine is maintained by our integration team. What it does is allows us to connect directly to these messages through TCP/IP connections and listen to them real time. So starting from the bottom left corner, we have our core point engine that provides us connections. And on the top left corner, we have what we call the HL7 listeners and processors. So what that is our custom build application that we built to listen to these messages real time. We ended up going custom development because some of the open source and other tools were not suitable for us. So the HL7, what it does is pretty much listens to these messages and pushes to what we call our queue system, which is in Event Hub, Azure Event Hub. It is a Kafka-based system that allows us to absorb the volume of the data that comes through. We keep it for about 4 days or so. From there, we have Databricks notebooks. What it does is actually listens to subscribes to the Event Hub messages, topics. We download this data real time. We parse the data. If you're familiar with HL7, we break down into smaller segments, and we push down to Azure Data Lake, which is our main storage location. We also use blob storage, and the reason we do that is because some of the messages are too large to be ingested through Event Hub. Some of them have attachments, PDF, images, so we store them in blob storage for processing as well. From the data lake, we have Delta Live tables that can also push data to other use cases downstream. Sometimes we have data in Snowflake, so we can merge with our historical data in our cloud data warehouse. Sometimes we push data to Azure SQL database that can act as a backend for Power BI applications or other web APIs that we have built. So we also have web services that we built, giving another option to ingest data through our systems. You can subscribe to an endpoint with a webhook, where you can provide an endpoint, it will push data to it, or you can just make calls to different web services that we have. We use Azure API Management tool. It is a tool that allows us to maintain and manage all these different web services that we ingest, not just from the streaming data platform, but also Fire API, some custom web APIs that we built as well, not related to patient. Data such as HR, Kronos data, and so forth. So the idea is to provide the user with few different ways to access data. One is through You can subscribe to an Event Hub topic. We have JSON parsed HL7 messages in there. You can access the data directly from Azure Data Lake or subscribe through web services. So that's a diagram in a very high level. There's quite a few more to talk about it, but let me move on real quick. So it is worth mentioning that we built our listeners in-house. So we decided to do that because it will give us the ability to control how we scale, how we manage and support. So a couple of things I want to mention about that. So the listeners are composed mainly of two parts. One is a Windows service that is deployed on an Azure VM that's constantly listening to a TCP/IP port for different message types. We have about 7 message types times 3 regions and times production and test environments. And what it does, it listens to these messages and places them in a temporary queue system or a buffer system. And then we have another process which is called the processor, again, and also a Windows service that's deployed, which listens to the, reads the buffer in the queue system real time and pushes data to either Event Hub or blob storage. The idea is to decouple those two processes, so we can absorb any high volume traffic or any bursts of message that comes throughout the day. Depending on the time of the day, we have high volumes around noon or so, and much lower volumes in the evenings. The other thing I want to mention is about orchestration. When we receive messages, we want to make sure we send an acknowledgement back to the core point interface engine to be able to receive the next message. So there's some level of orchestration that we have built in. And the way we build these listeners and processors are pretty much the same code base, but we added configuration. Our settings are configuration-based settings. In other words, we can just tell which ports to listen, where to send it to, what data type it is. Only through configuration, it would just deploy the same code base. And the idea is to provide high performance, easy to manage, and scalability through these options. And a couple of things real quick. I just want to mention that we received over a few thousand messages per minute across 52 hospitals, plus hospitals. We have 3 main regions, Alaska, Washington, Montana, Oregon, California, which includes New Mexico and Texas as well. Over 240 community connect facilities that we connect as well. Over 90 terabytes of data that we store for real-time streaming. We also archive some of those data sets for later use. We work in collaboration with the data science team to train their models. And we have about 81 notebooks and 65 clusters for all the different processes that we run. And just to wrap it up, a couple of things, couple of challenges and things that we noticed when we're building the system. Streaming data is not easy, especially for HL7 and healthcare data. It can be a little complicated, so plan ahead of time. Scale out as you need it. You don't have to parse every segment at once. You can start on demand. Also, keep in mind of high availability. Your SLA for us is about a minute or so. Make sure we always have data being delivered. And message orchestration as well. Make sure we always acknowledging the messages that we receive to ensure that we have a proper order of the messages. And also plan for backups and disaster recovery. That's the other thing we're working on. And having a support team that can always step in, especially in evenings or when there are any issues or network issues, it's very useful. And that's pretty much it. That's the high level of the streaming data platform. Back to you, Lindsay. Thank you.
So yeah, I think I would emphasize what Dalo said is that streaming in healthcare is a headache. Okay, Epic works really well for what it is, for running a hospital, for billing people especially, that's what it's really for. But getting data in and out of it is a chore, all right? And so like the fact that we like had to custom write all these parsers, right, just to be able to get that data out. And honestly, HL7 messages aren't that complicated. It's like, it's text with a specific set of expectations on top of it. Like it's not wildly complex, but there was a lot of engineering that went into doing this. I also learned like, through my experience with Databricks is that like lots of corporations, like streaming is how ingest happens. Like the fact that we in healthcare had to like do this after we were doing bulk ingest and do all this engineering, like, you know, it's a different challenge. So like if you want to talk further about like the technical engineering details, I encourage you to come up and chat with us, because like we want to share our knowledge around this kind of stuff. Like our vision is health for a better world. You can't help the world just by serving, even though we serve a lot of patients, like there's a lot more out there, so we want to share this learning. All right, so you know the problem, right? You know the product, at least the idea of the product, right? We have a streaming data platform. We know what's happening now in real time in our hospitals, okay? So you go back to that comment, right, from our stakeholders, our users, which is like, I don't need a dashboard to tell me I'm busy. I need to know when I'm going to be busy 6, 12, 24 hours into the future so that I can do something about it, okay? Ideally, even better, like give me some tips, right, around what I can do, what some actions are I can take. So to address this, we've been building machine learning. Again, you know, AI is just math, right? It's like, so we're building math into the platform here. And fitting models on top of these data streams, all right? So, you know, pro tip, Dalo alluded to it, but I'm gonna emphasize it, right? At the top, it's like data for data science team, train models, right? Like what we're really saying is that like we wanna fit our models on the messages, not on our historic data. Like Epic does a translation to relational data, to clarity, right? There's ADT data. If you like work in healthcare, you know this, you're like, oh, there's ADT data and clarity. It's not the same. Right, you can't fit good models on it. You really have to train on historical record of HL7. So building that up does take a little time, but it's worth it. You do want to store it. We maintain it like a year. We'll grow that over time to get better seasonal patterns. Right, you need something like that for a forecast. So we're fitting a variety of different models to address different challenges. Right, where we started was around occupancy. That was the whole project started in the first place, is how many people are there in an ER. It's grown from there. So we're like, okay, well, let's forecast occupancy, okay? And that's built on ADT data, all right? There's also some natural language work that we're doing here. I'll kind of like allude, you can't have a talk that doesn't mention LLMs. We'll talk just briefly at the end. We are also doing that, okay? But the most mature, the starting point is to build forecasting models on top of that historic admit discharge data. And as an aside, as excited as we all are about natural language processing, forecasting is super useful. Mathematical time series models are very productive. You know, they're non-trivial, but they're not wildly complex to deploy, and they solve a lot of very practical problems. So how do we do this, right? You know, if you remember, there's like these ways people could be admitted to the hospital. Many of them are stochastic, right? Like we want to predict something 3-4 days into the future, but that person who's being admitted isn't sick yet. Like, you know, like if I fall off stage and I break my leg, I go to the ER, but how would you predict that yesterday, right? We need an approach to that. So what we've done is implemented a 3-part hierarchical model. It's based on research and publications by Witt and Zhang. They're researchers from Columbia. We'd love to share the reference. It's like great work, right? So it's like the best in best like academic theory and idea, and then we've scaled it across 52 hospitals, and then doing tens and hundreds of thousands of predictions a day. So the first thing you need to solve for, that we start with, is predicting how many people will arrive on a given day. So if you do forecasting, you know the further you go out in your time steps, regardless of the actual interval, the fuzzier they get. So we want to keep a coarse time step for that first prediction. That's our daily arrival. So like we predict 100 people are going to arrive on a given day. that is then fed as a parameter to an hourly arrival model. We apportion those 100 using known seasonal patterns, right, within that day. More people are arriving at 9 a.m. than at 3 a.m., okay? And then finally, we have a length of stay model, right? And, right, you're like, if you're looking at that, you're like, well, how do you predict the length of stay when the patient isn't even sick yet, right? What we're doing is we're predicting a length of stay distribution for a population, okay, based upon our historic patterns, right? So it's like most people stay for a day, some stay for 2, fewer for 3. I mean, that's not really it, but it's a survival model, okay? So when you know the daily, you then break it into hourly, and then you kind of multiply it out across length of stay. You then have an occupancy model that you can then apply to every department. So here's some real data. Okay, this is from our Tarzana ministry in California, just a few, a couple weeks ago, right? On the right here, you can see our daily arrivals, and top and bottom, credible intervals. You got a middle point forecast, and then you've got our the actuals bouncing around a little bit on that. And if you fit forecasting models a lot, this is what you expect, right? I mean, one, if we've done our job right, we're going to stay in the dotted lines, right? That's kind of the point. And it gets a little bit fuzzier, right? As you go further out, you see a dip out there, but like we're doing a good job of capturing the core of the arrivals, okay? On the left-hand side is all 3 of them put together, okay? Translated into, very granular occupancy forecasts, right? Going out a week, okay? I think what is pretty amazing to me is how well you can actually model this, right? Like this is like again, these people aren't sick yet in most cases, but you can still predict how many people are going to be there and how long they're going to need to stay. Like this is like it's seemingly random, but it's not random, right? And the point I want to really call out and emphasize, if like either you are an executive or you are a data scientist or mathematician that has to explain this to an executive, is that the most useful part of a forecast is not the point forecast. It's the first derivative of the point forecast. It's the rate of change, right? So if you think about this as like being a nurse or a house supervisor, and well, I'm busy right now, but there's going to be a big drop-off in the next 3 hours, okay? I'm going to have capacity. You can send that capacity to another department, okay? Or conversely, if you know you're about to be slammed 12 hours out, you can start making plans for it, okay? And so I think that's a message like that I'm always evangelizing, and I see that as like probably the most valuable part of it. Although it is nice that we are pretty dang close to the actuals in terms of the occupancy here. So if you think about what you can do with this, right? If you go back to that mental model, right, of hospital flow, there's all these different departments, okay, right? You can now forecast out which departments are going to have space, where they're going to be beds, which are going to be, strained for capacity, and you can do it days out into the future. That doesn't intrinsically tell you what to do, but at least it gives you some forewarning so you can start applying your knowledge, your operational expertise, like all the tools that a hospital administrator and nurse has to address these things. I will add, so I guess this is the next one here. Get to LLMs in a second. Healthcare IT, traditionally not great, like we keep the lights on, but it's like not a modern tech vibe. We wanted to bring a product mindset to this, right? We wanted a tighter turnaround with our users, and so we've been building this with them and for them along the way. So we've now rolled out across like pilot locations, across Providence. We're going to scale like across our system over the summer. And at every step, we're collecting feedback, and then that feedback is just driving the rest of the roadmap. So I'm actually, I love it that we're past 4 stars, but I also love it that we're not at 5, because that like gap there is just like the next thing we're going to build. And some of the stuff that's on the screen here is like, we've done it. Like the top right there is like, well, this is great for the ED, but I don't work in the ED. Could I have it for my department, my unit? So like we did that, right? Same for admissions to the ICU. So this is like how we drive our roadmap here. And so, yeah, what comes next? So of course, like I said, we're scaling, right? We're going to move this across the system, right? So it gets in, broader and broader application. And then on the tech side, we as, technologists, data scientists, the first thing is like right now we're micro-batching predictions, right? While we work through the security implications for serverless and real-time ML endpoints. But like this is coming soon. So like every time a message hit, it'll just be in that diagram that Dalo showed. It's like message lands, it's parsed, hits the ML endpoint, forecast is spit out. So you're updating like to the absolute best forecast we can get. So it's just one way to improve the forecast. We're going to be putting covariates into our forecasting model, like, the usuals, weathers, financials, that kind of stuff. I personally am kind of skeptical this is going to help that much. I'm kind of doing it to prove a point because like everybody's like, well, if you just put weather in, suddenly you'll be able to forecast perfectly. Yeah. Maybe. I mean, we'll do it as scientists, but we'll be adding covariates. The third one, this is really LLM. It's not really chatbot. I think I probably could have done a better job on that slide. But this is around using NLP and LLMs to parse notes to do patient-level acuity prediction and predict discharge and order requirements. So will Lindsay Mico need an MRI, PT, a blood draw, a lab of a certain type, 24 hours out? And this is to give predictions once somebody's admitted and we know something about them, all right? And also build individual length of stay models. So this is like maturing very rapidly, and I think we're going to get there sooner than Q1 of 24. And then, finally, that's also too far out there. Unity catalog integration is actively progressing at Providence, and all these models, all these forecasting endpoints, they're all going to be accessible for the whole enterprise to build other things against, to build into Power BI, whatever they want to do with it. It'll all be in Unity. So I think, man, right on time.